the Technology Committee meeting for September 21st come to order. Call to order. Go ahead, clerk.
We have a quorum.
We have a quorum. We have what, 3? And we have 1 on the phone, right?
Yes.
Yeah, okay. Peter's on the phone.
Yeah.
Okay. Public comments relative to agenda items. Approval of meeting minutes of September the 7th, 2023.
So moved.
Second.
Are there any additions or Are there any additions or deletions? If not, all those in favor, please signify by saying aye.
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 Opposed?
Aye.
Opposed? Accepted. Item 4, presentation from LCI Corporation. We have 2.
Hi.
I'm sorry, Kelly.
Yeah, Kelly Shane, Chief Administrative Officer. I just wanted to introduce Chip Pless and Paul Russell from LCI. They're going to present on their thin film dryer. I'll leave it to them. And I think we're going to put their presentation up, which Julie is doing right now.
Okay. Gentlemen, welcome.
Hey.
Yeah, thanks for having us. I'll be doing most of the talking. My name's Chip Plus. I do work for LCI Corporation. This is Paul Russell. He's from Russell Resources. Russell Resources is our rep in the New England area. First of all, just really appreciate your time, to sit down and talk about our technology. Really going on a broad overview of where we could possibly fit into your current system or maybe even future systems or processes you want to put in. A lot of the details will depend on really more information on your mass and energy balance and what that might look like in the future and how we can fit. Oh, can I speak up? Yeah, I'll turn my volume up a little bit.
It's gotta be green.
Turn it off.
The green.
Did I turn it off?
Yeah, there you go.
Yeah, right.
Is that better?
Yes.
Okay.
Yeah, that's better.
So again, thanks for being here, and we'll go ahead and get started with the presentation. If you guys have any questions, feel free to pipe up, and I will answer those as we go along. Just a little background on myself. I've been in wastewater since 2010. For about 11 years, I worked for a company called Huber Technology, and I worked on belt dryers and solar dryers while I was there. And in 2021, I came to LCI. LCI was looking to expand the thin film dryer, which is very common in Europe and Asia, into the North American market. It was a very interesting technology for me, so I went over and come over to LCI in order to introduce that into the market. So I have a pretty extensive background in drying. And so, as I said, if you guys have any questions about drying, let me know, and we'll definitely clear that up. A little bit about LCI Corporation. We are part of the Netterman Group right now. We were formed in 1961 by a company called Lua out of Switzerland. And then we sell products into the evaporation and drying market as well as granulation and powder handling. I mentioned Lua Switzerland because our partner SMS, or Bus SMS Canceller, actually owns what was Lua Switzerland, which is in Pratteln, Switzerland, along with their manufacturing facility in Butzbach, Germany. So we're partners with SMS Bus Canceller. The dryer itself is produced by them in their Butzbach facility. We handle all service. We handle service, sales, project management, everything other than production of the dryer here out of our Charlotte location. So going through your RFI, I saw that previously you guys had an incinerator for municipal solid waste. And it looks like in 2012 you turned that over to a company called Mira, and at this point they are no longer incinerating incinerating solid waste. We would be on the sludge incineration side. We would be processing or drying sludge prior to incineration. As your memo recorded, you guys are solids limited by the DEP, so you are solids limited as far as what can go into the incinerator. I also noted you guys generate electricity from the incineration process, and that allows you to generate about $1.5 million a year in savings to your ratepayers. Just noted that your issues right now are treatment costs continue to rise and how to balance that with the costs that are going to be pushed onto your ratepayers. Sludge is becoming more difficult to dispose of, especially I think in New England is at the forefront in the country. Prices are rising significantly here. So I know you guys have a desire to possibly be a regional facility and help or bring in sludge from some other local municipalities. And then on the municipal solid waste side, it sounds like most of the municipal solid waste now goes out of state. And then ultimately you guys are looking for a way to increase or have some sort of trash to energy type options moving forward. So at the end of the day, today we're going to talk mostly about sewage sludge and how we can handle the sewage sludge side of things. Am I hitting the right button here?
Try pointing it that way. The computer's over there.
Do you have these? That's.
It didn't last long.
Just want to.
Okay.
All right, there we go. So ultimately, where our dryer could fit will depend on what processes you guys end up using or continue to use, what type of material you may need to go into those processes, as well as the energy that you would have available in order to process the sludge, either from that process or another process. We would be, at least at this point, a complementary process to, especially incineration. We would do pre-drying. We do not destroy any solids when we dry. We're simply removing the moisture, and a dryer is designed to efficiently remove that moisture from the sludge. We can do a lot of different things with our dryer. We've done preconditioning prior to many incineration plants. We can also do volume reduction, and we've looked at doing raw volume reduction simply for customers to go to landfill. We can create a Class A biosolid if that ever becomes an option again. And then we can also improve efficiency of processes, especially if we can find a waste heat source to be able to supply energy to our dryer. The other thing our dryer can do is we can fit one process today, and then we can modify the drying process in the future to fit another process. We're working with one client today who is drying only to, let's say, 40 or 50%, but they're making a process change where they may need to go to 70 or 80% dry solids in the future. So we're working with them to use the same dryers that they have already and change the process and the throughput to be able to fit that new process that they're going to be putting into place. And then finally, as I mentioned, our goal here would be to use free energy or waste heat or some sort of renewable, sustainable energy source to power or to heat the dryers. I won't spend too long on this slide, but I did an analysis, and I used about $10 per 1,000 cubic feet of natural gas, and I estimated, you're going to at least spend $20 per ton of each ton of water that you need to evaporate. I think it's probably going to be closer to 30. Obviously, it depends on how much natural gas costs, also depending on the efficiency of the system. So this is just a look at what it would cost should you be using natural gas as your energy supply. So we did put together a proposal based on the data you gave us. I think the addendum mentioned you may have slightly drier solids at 28% or something. We used the 25% from the initial RFP. We looked at drying that to 40%, and that would end up removing about 65,000 tons of water from the sludge, and we would need about 22 million BTUs per hour. which equates to about 21.5 thousand cubic feet or MCF of natural gas, if you were to use natural gas. And that would reduce the incinerator feed by removing the water down to roughly, let's say, 110 wet tons per year. When you end up drying sludge, most of our applications drying sludge are to increase the heat value or the calorific value of the sludge because the water is already evaporated. Obviously, looking at your multiple hearth, or I would say looking at your multiple hearth incinerator, if you were look to dry and you were looking to put dryer material into it, it would be something that an incinerator expert would really need to look at. I think I am not that expert, but obviously you've got how the incinerator operates, and then I think also emissions control is very important, obviously, with any incinerator application. And then, as I reported here, we had an extra zero in our equipment costs.
I was gonna say, next question, because when I read that, I said, I put it away, $80 million ain't gonna do it, okay.
Yeah, that was a major mistake. I didn't catch that one before it went out, but it was an extra zero as far as the equipment
Yeah, this
costs
is way
go.
better, 8 million is way better than 80 million, I was saying, wow, 80 million's a lot of money.
Yeah, I was surprised you guys came back to me after you saw $80 million. That wasn't, that wasn't
I
very
was trying to do
feasible.
paybacks and stuff this morning, I said, just no way this is gonna work.
Yeah, the payback of a dryer at $80 million just wouldn't
Ain't gonna
work out. So anyway, that's what you're looking at. That's the equipment cost. I know you guys asked about installed cost. From what I've seen, it's usually about twice that, maybe 150 times, depending on the building, construction cost, which are not, let's say, going down at least at this point. So those are just some rough estimates to give you kind of an idea where we can go. Just a side note, didn't put in this presentation, but we do have the ability to fit current buildings. We've done that a number of times. If you have a current building that might be able to facilitate the dryer, that's obviously some savings that you could see. Up on the right, this chart I put in is just, it's a chart showing moisture content or organic matter on the bottom, which is basically the fuel that we can use. And this is the percentage of organic matter in the material versus the moisture content. So this is the opposite of DS. So the 70% would be 30% DS. And so this is just a curve kind of showing you the energy content in megajoules per wet kilogram. And so it just shows you how we can increase those megajoules or the energy in the sludge as we increase the organic matter content and decrease the moisture content of the sludge.
If I can just ask a question, you gave us an example of drying to 45%, right? Dry.
Yeah, I think it was 40. Was it 45?
Okay, I thought you said 45, but that's okay.
Okay.
40% dry was 22 million BTUs per hour, right?
Right.
What is it to 90%?
To 90%, I think. So the mass loading goes down as you go up in percentage. So to get to 45% is probably about half the water that you're looking to evaporate. So a rough number is you're probably looking about double that.
Okay, so basically you're going to double that. So you're talking about 45 million BTUs per hour, right?
Yeah, it might be a little bit less. Normally when we evaporate, I won't get into the physics, but when you partially dry, you use more BTUs per every pound you evaporate. So when you get up to 90%, you'll actually decrease your BTUs per pound. So it's probably going to be a little bit less than that.
So 40 to 45, roughly.
Yeah, I would say something like that. I mean, I can run the calculation.
No. It's I just and you gave a dollar amount, $30 per wet ton, right? That's the assuming $10 per. I don't know what you right.
Yeah, that was just a rough calculation.
I'm just trying to understand. So to get to when you say $30 per wet ton, but is that to what? To just to 25%, or is that to 40, or is that to 90?
Well, that was 30. I would say that's $30 per every ton of water you evaporate. So, take your tonnage of water you want to evaporate per year, multiply that by 30, and that would be a rough cost, assuming my cost of natural gas is.
That's fine. Just rough guesstimate.
Just rough guesstimate, yeah.
Okay, thank you.
I know you guys also talked a little bit about greenhouse gas emissions. I know it's a concern everywhere, right? Climate change and everything, especially in the industry we're in. The point I wanted to make here, and I won't belabor this too long in the presentation, is per the EPA, 1,000 cubic feet of natural gas produces about 0.55 metric tons of CO2. Multiply that by 10%, 110%, and then you get to our US tons, as I call it. So it's about 0.06 US tons. So if we were using 25 MCF, you would be looking at like 1.2 metric tons of CO2 per hour should you burn natural gas. If we were able to use biosolids or biogas or something like that, it's considered biogenic CO2, meaning it would naturally cycle back. We're not pulling stuff out of the ground that was put in the ground millions and millions of years ago. So that's considered energy neutral. Again, if you could figure out a way to use some of your incinerator heat to be able to dry, then you would be able to reduce that CO2 emissions.
So I'm just gonna clarify my question again. So I'm just assuming, let's assume we're at 175,000 tons, wet tons per year.
Yeah.
We're gonna dry it to 90%. So assume you're drying 175,000 tons of water, right?
Yeah, so it'd be slightly.
Whatever the number, it's close, right? 150, 160, whatever the number is. So you're saying $30 per ton, so that's about $5 million a year to dry with gas, to dry this to 90%.
That would be correct if you were end up using natural
About
gas.
$5 million.
Yeah. It'd be a little bit less because you wouldn't be, you would take the solids out of that.
Got
like
it.
40,000
Yep.
tons. But yeah, you're looking at probably 175 minus probably 50,000. So you're looking at 125,000, to get to 90%.
Yeah, based on what Scott was saying, latent heat of water is like 970 BTUs. You could say you can flash it off at 1150. We have, and assuming the savings we would have is whatever you could do more efficient. I think this is a pretty efficient number versus what we heat through our incinerators, whatever we could do ahead of time. Do we have any idea what our incinerators efficiency is versus 1150 to get rid of water ahead of it? Do we have the numbers that you guys? I mean, that's where the money savings is. I understand the $5 million, but you're 1150, and if we're at 1250, the difference is. That's the pure savings. And the question is, can we do that for $8 million? And I wish I saw the $8 million because I saw the $80 million. I just kind of stopped. But isn't that the true money savings though for us right there? That's it.
That's what a dryer does.
And
right?
do we have that by any chance? What we can do?
We know our incinerators are running at about 85% efficient, right? In terms of what I guess the question is,
Let me clarify.
Yeah.
So they can flash off water at 1150 BTUs per pound, whatever it is.
Yeah.
What can we do that for, go into our incinerators? I assume they're probably more efficient than us.
Well, let's just use basic numbers, right? So how much gas do we burn at the treatment plant?
$2 million.
I don't have that.
Yeah, that's tough. But you're burning sewage too, though,
Yeah,
right?
we just budgeted that number. What is that
$2
number?
million, wasn't it?
It was just went through the budget with it.
We don't spend $5 million.
Yeah, so just think about the question you just had was, forget about the efficiency, right? We burn 175,000 tons of wet sludge, 125,000 of that is water. And we burn it in our process prior to pre-drying with less than $3 million. So
But you're also you're burning sewage too, though, once you sow.
it doesn't matter. Forget it. The end result
Yeah,
is
you gotta get rid
you're
of the
spending
water.
3 versus 5. I think the question, this technology is, probably not so much an application for the MHIs, but more of an application towards pre-drying a MSW Deep would say they want you to separate all of the wet stuff, right, the food and everything.
Yeah.
And that affects the efficiency of the MSW. If you're gonna mix in MSW with solids or something, and you need to pre-dry that. But to pre-dry the MHIs, you're doing the same thing that the MHI is doing already.
I know you're doing the same thing. Question is, are they doing it more efficient than our incinerators are? And I can't.
Well, I
on
answered
what
your
you just
question.
said,
Your
you
question
said
is, it's
it's okay.
$5 million for gas,
It's less than
and it's $8 million for the equipment, and we're spending $2 million. So it's a different way to do it. You're getting the same results. The only other thing you've got to consider is,
But you only pay for the equipment once, right?
right, no, you're only paying for the equipment once, but the only thing is, and I don't know the answer.
The question though, I don't know the answer either. Are they heating the water up ahead of time cheaper than we are in the incinerator?
Well, they just
That's it.
answered the
And
question,
no,
it's
the
5
answer
million.
question, you're saying it's
versus
not.
two.
Well,
Yeah,
Yeah.
that's if we dry to 90. But
Right.
what we would do incinerator-wise is we would try to use waste heat from the incinerator and then only dry up to what you needed to be energy neutral.
Got it. The only reason why we're going to 90 is I'm asking this question because one of the RFI, the whole idea of the RFI concept was a MSW type of a plant, trash to energy. And what would the logic that we thought your equipment was interesting was, even though it's really designed towards the sludge piece, pelletizing for gasification and those kinds of things, was how could you use this equipment in an MSW / biosolid / medical waste type technology, and how would that fit? And how would it fit? And one thing that we've learned in gasification process is they need to dry to 90%.
You're right.
That's why I'm asking the 90% question.
Yeah.
To understand that and how it worked, how it would work,
Yeah, so I mean, I've got a little bit of that later on, so maybe I can try to answer some
problem.
questions. I did put some gasification information in because I noticed that was in your guys' RFI.
Sure.
And where we could fit there. Again, it's about mass, energy, and number, right? It's end of the day, it's dollar value, right? Because that's what you guys are trying to get for your ratepayers is you're trying to maintain the best rates that you can by reducing your cost as far as you can. I'll go through this shortly. We have done a lot of different stuff. Speaking of co-incineration, we have about 30 plants that are drying prior to co-incineration, anywhere from 50% to 90% DS. So we've done that. We've done pre-drying on mono-incineration for sludge only. We've pre-dried for agricultural use like Class A. We've also just dried for volume reduction to go to landfill for some customers because that makes the most sense for them. We did do one gasification project back in the late 90s in the UK. It got abandoned because the gasifier couldn't be energy neutral, so they moved away from it. But we do have...
What do you mean by that, energy neutral?
So in Europe, most sludge is digested already. And when you digest your sludge, which you guys aren't doing right now, you reduce the energy content because you're generating, that energy is being turned into methane gas. So when they go to try to pyrolyze or gasify or even incinerate the sludge that's been digested, there's not enough energy to make it energy neutral.
We don't even want digested material in our incinerators.
The point is, and that's the thing with Europe, they were wanting to produce the gas all the time, so they're already producing the gas. Now they're looking to incinerate, but they're trying to figure out the energy balance. I mean, you got sludge, there's so much energy in it. You can digest it, get some of the energy out, there's other ways you can get energy out of it, but there's only so much energy in the sludge, so to speak.
Can I ask a
Yep.
question based on that? In your questions and answers, you made a statement. In Europe, gasification and pyrolysis have mostly been abandoned due to the insufficient energy content of sludge for achieving energy neutrality. The reason I bring that up, we've been looking at it, and we keep looking for why we can't find any plants. Is that the reason? We have a lot of salesmen come in and tell us all these wonderful things, but that maybe is the reason why we can't find any. Because of that. I'm not sure if I understand it, but that statement I circled it because I said, wow,
So in Germany, they've pretty much abandoned it because they could not make, especially the digested sludge, to energy neutral, right? So
Why do we care about energy neutral too? I'm just curious. I know they're there, but why do we care about it here?
That's just a statement of why they abandoned it in
Okay.
Europe. because they are looking for energy neutral, zero carbon type emissions in Europe. So, and pretty much all sludge in Europe is digested. If you're going to burn sludge, you don't want to digest it. That's the point, and you guys don't have digesters right now, so you have the best case scenario to burn the sludge.
Once you start in a path, you either digest or incinerate. You don't do both, right? We purposely don't digest because you cannot land apply the byproduct at the end.
It caught my eyes, why we can't find any plants in Europe.
But my
He said
point
why.
is, to their point, we set our stage in 1970 when we built incinerators. Other people have decided to do digesters. But in Connecticut, you cannot land apply, right? You cannot land apply
No,
application.
New England, you can't either.
And now with PFAS, you can't do it anywhere. It's a taboo. So that's why the MDC went with incineration because of the regulations in Connecticut. But they don't have any gasification units.
Well, especially in Germany, they made a law that they were going to go incineration. So the country made the law, this is the way we're going. A little bit of that was for
What
phosphorus.
kind of incineration?
Usually fluidized bed,
Fluidized bed.
because it's the newer technology and usually has the lower emissions. So most new incinerators are fluidized bed. In the U.S., I think pyrolysis and gasification has really popped up in lieu of incineration because of the EPA's regulations on incineration, and they consider pyrolysis and gasification as non-combustion technologies.
Non-flame.
Yeah, and I think that's the main difference that you're seeing here, because I'm not, again, an incinerator expert, but from everything I've heard, if you don't have an incinerator already, it's next to impossible, or it's very difficult to get it permitted through the DEP or EPA.
But why would Germany, if
What are they using?
if Germany's going to fluidized bed because of emissions, why wouldn't they go to gasification?
They're very concerned about the energy neutrality.
Okay.
So that's what they're looking at. They also feel like they've got the treatment systems on the back end to be able to clean the
Emission
materials.
systems,
Yeah. And again, they consider burning it biogenic. So they quote unquote aren't adding carbon to the atmosphere because it's carbon that was produced and would go back naturally anyway.
Really interesting, I don't know. There's not dumb people over there either.
Yeah, it's a different mentality. Like if you talk to Europeans about what we do, they don't understand it. And then I think we don't understand what Europeans do. It's just a different, I wouldn't say either side's wrong. It's just looking at it two completely different ways. And you have to remember energy costs in Europe are significantly higher than they are here. So that's another factor with the energy neutrality. And then I'll just end. We've been drying sludge since 1985. So these dryers are well proven out in the industry, and we have one in Wacker, Germany. This dryer's been operating since 1985. So from the robust side of the equation, installing this equipment, you can probably expect about 40 years, if not a little bit longer, out of the equipment once you install it. And then also be able to switch processes. So, hey, we're drying to do this now. We want to change our process. We can reconfigure the same dryer without having to go through buying the new capital equipment.
And we did talk about this in the questions. Obviously, there's a component, a carbon component to emissions. So you're going to burn $5 million worth of natural gas.
Air quality issue.
So what did you guys look at that in terms of what you would think in terms of additional carbon we would generate?
Yeah, so I didn't run the exact number, but as I said, it's probably about, the EPA says burning natural gas every 1,000 cubic feet is 0.6 US tons, 0.55 metric tons. So if you multiply that, I think I said somewhere around 25, 25 MCF per hour times 0.55. Whatever that calculates out to would be your carbon emissions per hour. I think it was 1.4. Didn't I put that in the
1.4
presentation?
tons per hour.
Yeah, that's drying to 40%. You'd obviously use a little bit more energy if you dry up to 90%, or about, let's say, roughly twice, just for the rough guesstimate. Yes, sir.
Not to interrupt your thing again, but assuming the numbers did work, and you were more efficient than us to dry, even though Scott says no.
Well, just go by the numbers, I don't know.
Mechanically, we pump wet sludge into our incinerators through a pipe. And again, I could be wrong, but so now how will we change our system? We'll go with screw feeders or something? Would this be a big deal? Could we handle that, or is that something to be a major retrofit for incinerators?
It's a good question. Probably better for, the incinerator people.
Yeah.
You would pump to our dryer. So you would pump directly into our
But
dryer.
we have to get from your dryer into the incinerators.
You
and
do.
That'd be something different.
I know, I was gonna show a European installation. They do convey. They use conveyors
Screw
to
fix
go
conveyors,
to go
I'm just-
into them. Yeah.
Again, that would be a setback cost-wise to figure out how
Yeah.
to do that.
Yeah, it'd be a process issue, which could affect, a lot of things, but
That
we
8
don't
million could go
know.
right to 80 million.
Well, you don't know, right? I mean,
Real fast.
it's logical to weigh those, do you do this first? It's really like, do you pre-dry first, or do you just burn it more wet the way we're doing it? I don't
No,
know.
like I said, it all comes down,
Right.
you're saying no, and you're probably
Well,
right.
I'm only saying no because 5 million, I know I'm
Yeah.
spending 3, right?
Yeah.
I just, now would it make the infrastructure more efficient so that we could get the 85 up to 95% efficient? And would that save us enough money to pay back the extra $2 million a year in natural gas? I don't know. I'm just saying, based on the numbers.
What's that do to the carbonization issue? Doesn't it,
Well,
the
it-
discharge, the air quality becomes.
I don't think it does anything, right?
Issue.
Sewage is sewage, right?
Well, no, you're burning, the thing you've got to worry about is you're burning natural
Natural
gas, right?
gas.
So you're gonna burn more natural gas, you're gonna create more carbon.
Right.
So,
The carbon footprint
yeah,
increases.
and that's why, the logic for us was, we really liked and wanted to look at your technology because of a new process of MSW that's gotta get dried, or the gasification system, that would need, 90% dry in order for it to, burn MSW slash sludge slash, wet noodles and those kinds of things. And how would this fit into something like that? If our incinerators instituted a pre-drying component when they designed it in the 70s, it would have been different, because, the system would have been designed to handle that. It's just a little, and not something we shouldn't look at. It's just a question for,
It is, and if we did dry, we would more than likely only dry to like 45% just to get you to energy neutral, which would, the goal of the dryer would be to use, if you had any additional heat available still from the incineration process, would be to use that heat in order to pre-dry. I know you are directing most of it to I guess, a turbine right now.
turbine,
right?
yeah, steam turbine.
So, again, I'll show you an example here in a minute of kind of what they've done in Europe, and it may make it a little bit more clear, or may add some more questions from you guys. So, but yeah, again, if you look at this, is a very, very busy diagram, I know, but the main thing I wanted to point out is we can dry to pretty much any level, and we can, be used as a fuel for incineration, and I even put pyrolysis and gasification, and we're assuming we're going to dry to 90% for pyrolysis or gasification side. The reason I put this in is we only exhaust about 5% of the vapor. 95% of it would be condensed back and sent back as liquid to the wastewater plant. So that 5%, the largest dryer puts out about 200 CFM. So from a treatment standpoint, if you're incinerating it, you would just direct that 200 CFM back to your incinerator air, and you would oxidize it with the incinerator air. Or if you're using a boiler or a heater, you would send it back there. Since it's such a low amount of air, it can be mixed with the combustion gas and oxidized that way. And I know you guys don't have any use for the heat recovery, but we can recover heat off that condensation unit, and it can be used for a bunch of different purposes, typically digestion, which you guys don't have, but also building heat. And again, Europe does things a lot different. They have these district hot water systems where they're pumping hot water out to the community. They've used it for that as well.
Hospitals and things.
Yeah, like a hospital or a university, they usually have these central plants. So the main thing we were talking about is energy. I think we've talked quite a bit about this. The one thing I will talk about is dryers have different efficiencies. And our efficiency, when we're drying to 90%, is right around that 1,150 BTUs per pound of water at the dryer. Some dryers are up around 1,600, so just something to consider when you look at drying technologies. There is a significant difference between them. I mentioned the heat recovery. We talked about we can decrease the water content, and at the bottom, my partial drying point is if you only need 70% or you only need 65, there's no reason to go to 90, right? It's just a waste of energy. Now for gasification, I've seen as low as 65, but I think most people want 80, if not 90% going into the gasifier. So you are looking to have to fully dry at that point.
Do you guys do any pre-drying for gas, or do you do any pre-drying in Connecticut for any of our waste? There's some firms some agencies, and I know Boston, they pelletized, they were doing it selling it for fertilizer, but then the issue with PFAS came along and land applications got. But do you guys, do you have any plants that are pre-drying and pelletizing?
No, the one plant that we have, and I'll talk about it, is Middlesex County, which is down in New Jersey, about
Okay.
20 minutes from Newark,
Okay.
about 20 minutes from the Newark airport. They have an interesting process. They lime stabilize, but they needed to decrease their volume. So they and I have a slide later, but they dry from about 20% cake up to about 55%, and then they blend a lime with it. They are a Class A product with the lime, but they were having problems getting rid of the Class A product. So when they decreased the volume of drying, they could direct all of that to their local, the municipality's own landfill is Top Cover. So that is an application, and they welcome visitors. They've been running since 2008. If anybody wants to go down there and see it, it's a pretty impressive facility. I think they're 120, 125 MGD rated plant, so it's a pretty big plant.
Yeah, but what do they do with PFAS? They got a problem.
Well, yeah, that's a problem.
I mean, the major issue we're looking at is PFAS too. And
Yeah.
and then there's the air quality issue you gotta solve, so
Yeah.
carbon you're putting out.
Yeah, it's a complete process, right? So drying is not going to destroy PFAS. It's not high enough temperature. Basically, you're drying at boiling, right? Maybe 200, maybe 230 degrees. The studies are showing time, temperature, and turbulence from what I've heard through incineration, through gasification processes. I don't know if there's been a definitive study yet that says that these things have destroyed PFAS, but I know that's kind of the current thinking is some sort of thermal destruction that would be required to destroy that carbon-fluorine bond that's in the PFAS.
Well, don't most of the studies establish the heat level to destroy PFAS?
Yeah, so
One study did, and
yeah, and then
around 1,100 degrees centigrade.
I've heard that number. Then I've heard lower numbers based on how long the material stays inside the incineration process, and then I've heard other consultants say, yeah, there's also a turbulence to it. How much are we turning over? I think we're just in the infancy of looking at it. I think they're starting to look at some of the incineration processes. There's not a lot of gasification, not a lot of pyrolysis units out there to do a lot of testing on. So I think the jury's still a little bit out, but I think those are the technologies that would end up destroying it. I think the big question now is making sure it's not going up in the air, because that would be a big concern. Is if, okay, we're incinerating it, we're not destroying it, and it's going out through the stack somehow.
The challenge that we've talked about here internally is, when we dewater, we're dewatering and we're burning this with solids. We're not destroying
The water.
PFAS in the dewater, So
Right.
you just said 175,000 wet tons per year only 50,000 of it is solid. So 125,000 tons of water is going back to the Connecticut River without being
Or someplace
burned,
else.
incinerated. So 10% of your waste is being incinerated or pyrolysis, but you got this massive, 80% of what you're processing is going back into the river, polluting the river, polluting the groundwater table, blah 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 blah. So it's going to be interesting to see how EPA handles this PFAS issue.
Well, I'll tell you another interesting point talking about Europe. They've backed off on their whole PFAS thing. And the funny thing to me is it's based on basically the lobbyists from the manufacturers have influenced the politicians there, which, just a side note, kind of, made me laugh a little bit that Europe is now backing off on something that us Americans are now look like we're
Are
taking
you
the
talking
lead
the
on.
manufacturers that make the Teflon and PFAS, or the
Yeah.
equipment manufacturers?
No, the manufacturers of
Like the pans.
the people making money off PFAS. Yeah, that's the people.
That's
And
odd that lobbyists would,
yeah, I mean, I think
politicians' mind.
That's happening here in the United States too, because
Oh,
what's
yeah.
happening is the only thing they're focused on right now is the drinking water standards
Right.
but no one's talking about banning Teflon pans, right? So we already know that the number one source of PFAS is landfills, and no one has said stop building Teflon pans. It's
exactly, or nonstick coatings or
Right.
whatever,
Right.
that make our life a lot better.
right.
So,
Yeah.
yeah, it's a long-term topic. I mean, I'm obviously not at high enough level, but I've heard rumors inside the EPA. There's different philosophies, right? I think what they're doing is they're rolling back their time frame. They're saying, okay, we want to get rid of this stuff, but we can't do it overnight. So let's roll it out over the next 5, 10, 15 years, something like that. So, but that doesn't help us, right? So us in the water industry, we still have to deal with the stuff here in the U.S. and make sure we meet those requirements. We talked about this already, so I'll skip through it. It's basically just telling you that if you digest your sludge, you're losing energy that's going to go into your incineration process. This was just a diagram showing, the supplemental energy and the waste heat could possibly go away with the thin film dryer if we could reuse some of your waste heat in order to dry, which led me into this facility in Mainz, Germany. It's a regional facility. They process Mainz wastewater as well as 92 other local plants. It is a fluidized bed incinerator, but they use our dryers. They dry from 25 to about 45%. And they're a net positive energy facility. So what happens is they incinerate, they create about 30 million BTUs per hour. They create a steam, they send the steam, create about the same as you guys, about 1.7 megawatts electricity. Then they take the low pressure steam, send that to the dryer, pre-dry, and then they recover the heat off the dryer and sends it to a district hot water system. So
Why isn't that the same as what we have?
this facility was started up in 2001. So this is really a state-of-the-art facility that's being put into Europe. And I think, to your point, you're looking at incinerators. You said the 70s, I guess, was when
Yeah,
you guys
70s.
put the incinerators in. So if you were putting a new incinerator in today, this is probably what you would look at doing.
This would be more of an application, sorry, this would be more an application that if you start from scratch and you could.
Well, again, 10 years from now, maybe we will be, I don't know.
Well, yeah, but you still have just like the digesters, the system was built in a way to operate a certain way, and to change it, you'd have to change almost everything. So that's the problem with it. But to your point, we're using steam at whatever temperature and pressure, and when you use that, you're using it to produce 1.7 megawatts. But when you're discharging steam off of that turbine, you've dropped the pressure down, you've got the volume down, but it may be enough to utilize to instead of spending $5 million in gas, to use that low pressure steam to pre-dry. So there's things that there's a lot of processes that you have to analyze before you can say, is it beneficial or not?
Yeah, I mean, I'm here just to show you guys some options.
No,
of
this
what's
is
out
great.
there.
This is excellent.
You know, every plant's different, right? And again, none of us, you have unlimited funds, right? If we had unlimited funds, we'd probably start over again at these plants, but we just don't have that option. So then it's an option of like, hey, what do we have? What can we use? What makes sense? What makes the financial payback? So, I think, in my opinion, you guys should probably look at your energy, your mass balance of what's out there, what could be used, and what's cost effective for you guys to put into service, either in a short term or a long term standpoint.
And in terms of, so using low pressure steam and or, I don't know what our exhaust is is it 1400 degrees after the incinerators, the heat exchangers? Tom?
So it's going out of the incinerator into heat recovery at about 1400, and it's coming out probably 600
600.
out of the boilers.
So so the question would be, looking at that kind of stuff, how is 600 degrees Fahrenheit exhaust enough to help pre-dry to some number? But I think it's a great.
Is this off the cogeneration talking about? We're coming out of that?
Yeah, we're coming off of our incinerators at 1400, but we're using that 1400.
Oh, I understand. But
But
600
then you drop that temperature down to a certain number.
Even 600 degrees is pretty
Yeah.
high temperature steam.
Yeah,
That's
yeah.
still pretty high temperature
Yeah,
steam.
yep. No, it's air emissions. That 600 is air emissions. Yeah.
You'd have to put a heat exchanger in,
Yeah.
probably a second heat exchanger.
Yes.
Either that or change the the system that's already there to pull
Yeah.
out more heat.
Yeah.
So, and that's what I'm saying these new systems are doing. They design it from the ground up. And then with a current system, again, I'm not an incineration expert, but you got to look at, okay, 600 degrees, we need maybe 350, 300 degrees steam or thermal oil go into our dryer to be able to efficiently dry. Maybe it's enough you can pull off. You have to look at your BTU numbers and your temperature delta. And the other thing, I don't know about is how that may affect the emissions equipment downstream.
Yeah.
That's.
So if we were building a new incinerator, similar to what they did in Germany, this would definitely be a technology that you'd want to start from scratch in designing, right? Because you'd be able to make all those decisions on paper.
Yep.
On an engineering level to determine, the pros and cons of the emissions versus, what temperature do you, if you need 300 degrees or 350, you could design that into the system rather than trying to retrofit something.
Yep.
Does I don't know if you know, but Middletown, town of Middletown, their incinerator, Tom, that's a fluidized bed. Do they pre-dry there?
No, I don't believe so.
No.
I don't think many people in the U.S. have done pre-drying,
Okay.
just because of the.
Stanford did, though. Are you familiar with Stanford?
I am from Stamford, Connecticut.
Yes.
Yeah, I am. They now they have a drying facility. I know, right? That's run by Synagro, or
Tom,
am
do
I
you know?
thinking of a different facility?
The town runs it. I don't know if they have a
Okay.
contractor to run this facility.
Yeah, it's contract ops at this point, I believe.
Yeah, they said it must be Synagro.
When you
But they
talked about-
pelletize there
They pellet-
Right.
with a pre-dryer. Is it,
Yeah.
is it your equipment that pre-dries?
No, they have a drum dryer, I
Okay.
believe. Yeah. So I didn't get into the differences in our dryer. It's something I can get into in another presentation. But
Yeah.
there's pluses and minuses to the different dryers. Usually with drum dryers, you're not going to partially dry. You don't have that option
Okay.
because they need a back mixing system because they can't come in with the sludge because the way that it tumbles, it creates a big glob. So they're usually back mixing dried sludge, which I don't know if you guys knew, they had an explosion there, I think, in 2019, I think, at that plant, which I know is one of y'all's concerns.
Yeah, they've had a lot of problems there.
yeah.
That's
So-
Stanford?
The difference with our dryer is we would just take the sludge directly in. We operate in an inert environment, so we take the oxygen concentration down below 8%, which is below a level where you can have fire and combustion. So we're a very safe dryer. They also produce a lot of dust with that back mixing system. It's just a very dusty application. So yeah, there's different dryers, and there's different advantages and disadvantages to each dryer.
Yeah, but not pre-drying.
Yeah.
Sorry.
So I will tell you, it's not our dryer, but Green Bay, Wisconsin, I think, is the latest facility that started up a fluidized bed incinerator, maybe 2015, 2016. You can look it up online. They have a lot of information on it, but they do pre-dry
Okay.
before their fluidized bed incinerator.
And supposedly, Tom, there's one town in Jersey are building like 5 new fluidized beds. I don't know if they're pre-drying. Yeah. Do you do any pre-drying for MSW plants or?
Yeah, so we've done all kinds of drying. We've done the co-incineration, so some are municipal MSW combined waste, some
Yep.
are hazardous waste, and some are industrial waste combination plants.
And what do you typically dry MSW to?
When I looked at our list, I saw anywhere from 50 up to 90%. I'll be honest, I don't know why you have those differences. Probably a lot to do with the energy balance and or how they're feeding, and maybe how much we know what their blend ratio is of sludge to municipal waste. But that would be a situation building a new incinerator for a co-incineration with MSW, where you could look at the energy balance and figure out, hey, if we do need to pre-dry the sludge, do we set up the system there to have that energy available for the drying system?
Well, the one nice thing about, we've had, discussions with Deep, and just general discussions about MSW and the need to or not to recycle, right? And food to waste recycling is very popular and very much a concern of Deep. The question I would have for Deep is, if we had a pre-drying facility, that therefore we didn't have to recycle, because obviously we're burning wet noodles, right? We're burning wet tomatoes, and so if you had a pre-drying facility, would they allow an MSW plant to not recycle that food to waste piece? I don't know. I don't know if Deep is on the phone, but
Gabrielle Fergon is on.
Gabrielle. Gabrielle, are you there?
Oh, she left. She
Oh,
wasn't
she
there.
did. Okay. Yeah, that's a question for us, for them is, and when you do the cogen, the work that you've done with pre-drying, MSW, and cogen, what is the typical cogen component of the plant? Just steam or?
Yeah, typically you're going to generate steam, and then you're going to do a steam turbine
Turbines.
to generate electricity, then try to take the low pressure steam.
Yeah.
The other thing we have is we do have a dryer that the dryer will operate under a vacuum. Not to get too technical, but when you operate under a vacuum, you lower the boiling temperature, which means you can even use even lower temperature waste heat, maybe hot water or something to that extent to do your pre-drying. So there's a lot of new ideas out there, a lot of new. The dryer's been used. We have 120 municipal sludge drying installations, but the dryer's also been used in industrial processes, and so it's designed to dry under a vacuum for those processes. So it's already been doing it, huh?
Kind of like refrigerant.
Yeah, kind of like refrigerant. Yeah, so yeah, we would basically, you could take the drying temperature boiling point down to 115, 120 degrees Fahrenheit when you operate under a vacuum condition, which would lower the temperature you would need to heat the dryer with.
I should have picked this up. Are these batch dryers?
No, continuous.
They're continuous.
Yeah.
So how do you pull a vacuum in a continuous dryer?
So on the discharge of the dryer, typically you have 2 gate valves.
Yeah.
And so one gate valve will open, it'll dump the material in, then that gate will close, the next one will open and it'll drop out. That's typically how you do it.
You're doing little bumps like those.
Yeah, I mean, it's
I get it.
continually doing this. That's how we would use for example, if it was a solid material. Now, if we're drying and it's still like a cake, you can actually just put a cake pump underneath it, and then the cake pump is its own plug, because you have the, basically you have the solids, and then you have a sealed discharge chute into it. So there's two ways of doing it depending on what the material
And
looks
how do
like.
you deal with, so for MSW, how do you deal with things like, you know, even if you recycle, you're not going to catch everything, right? So how are you going to, what component of MSW can't you pre-dry? I mean,
So we
not going to pre-dry plastics or plastic bottles or.
So really it's the sludge, right? That's what we're drying with our equipment. We wouldn't be drying the solid waste, so to speak. That wouldn't be what we would do. Now, on the food waste side, again, it depends on what you're looking to do. There's a lot of people who are digesting that, and then they create a slurry. There's a lot of people looking at this manure and chicken litter and creating digesters. Those would be the type of slurries that we would pre-dry. We wouldn't touch the solid waste. We need the dryer is designed for like a semi-solid material to come into it, like a cake, or more liquid than that, something like that.
Further questions?
Yep. What does this do in terms of your staffing or manning levels at a facility?
So good question. The mines plant had 3 individuals running the entire system in their control room at a time. Normally, when drying's put in without any incineration, the dewatering operators operate the dryer as well. And I would believe your incinerator operators, it's designed to be fully automated, would be able to operate the dryer along with the incinerator at the same time. So they're designed to run unattended 24/7.
Well, I guess would this have any impact in terms of netting out people that are currently employed there in terms of the multi-hearth incinerators or not?
No, if this was made a good business decision, I mean, it might take some additional training, but just like the heat recovery plant, Tom and his staff instituted that, and we utilize the existing staff to do it. So this would probably be the same thing. It wouldn't be a difference. You know, that issue came up, Commissioner, with the gasification, where they said they only needed 3 people to run that plant, and we have, you know, they gave us a guesstimate of saving, you know, $4-point-something million a year in staffing, because they did, you know, so that this wouldn't affect the staffing level.
No, yeah, this would just be, it would be something run 24/7, and mainly, you know, you're just keeping an eye on the operation like you do your incineration systems. I have a few more slides of it. I went through a few digestion, you know, scenarios where we would recover the heat. I know you guys probably aren't looking at that now, but I know I saw in the addendum there was a lot of talk of digestion questions when the addendum came out. So if that's something that's looked at, again, what we would do is we would dry the digestate, and then we could use the same energy to power the dryer, then send it at a low temperature, say 160, 175 degrees to the digester, and that would facilitate drying and fully heat or partially heat the digester without any supplemental energy. I think at the end, I talked a little bit about, here's the pyrolysis. So normally with pyrolysis, you're creating that biochar, and then you're creating syngas. So what they want to do is normally they burn the syngas and generate heat for both the process and the dryer. This is where it becomes tricky. I believe most people think that there's enough energy in undigested sludge to allow the pyrolysis unit to operate with the dryer with net zero energy, where you're not having to add natural gas. With digestion, I've been told it doesn't work out because you've already lost enough energy. So this is just a point, like with other dryers, especially convection dryers, that's usually the end of the line for your heat. But if you guys do have a usage for 150, 175 degree hot water, we have the ability to pull that off, whether it's heating buildings, like if you put a new plant in, it could possibly help heat the buildings in the winter and things like that. Click through these quickly. Mainly, I was just showing you here with digestion, a lot of people are creating, pipeline renewable natural gas and they're burning gas. And again, the other dryers, they're going to pull this heat off and then just dissipate it in the air and then heat the digester with the other heat. Here, we would just take a loop, put our dryer in, recover the heat, put it back into the digester, creating a nice circular loop there. Talked a little bit about the exhaust vapor, which if you're using incineration, we would put that back to the incinerator. It's only about 5%. You would have 95% of that water coming back to the plant. So that's, a consideration from the process side. You take however many pounds of water you're evaporating, divide it by 8.34, that's how many gallons per hour you would be sending back to the plant. Normally, you're looking at really depends on the size, but you're usually looking at 20, maybe 30 gallons a minute that are going to go back to the plant from the dryer. So, with the 5% being discharged, however much you evaporate, that's roughly how much you're going to send back to the plant for processing. I mentioned the safe operation. The maintenance side of things, so Middlesex will be undergoing maintenance there in late October. So what we do is we have these little blades on the unit. I know I didn't explain how it works, but over time with grit and trash, these blades wear down. So once a year we pull them out, we check the blades. You kind of run a string, or you do run a string, you check your gap, you replace what needs to be replaced. At Middlesex last November, one dryer needed no blades replaced after 6,000 hours. The other one only had about 10 to 15 of these individual blades replaced. And we have this pre-configured trolley system where you would pull the rotor out. It does basically double the length for maintenance, but normally we put a roll-up door right at the edge of the motor. Then you pull it out into a parking lot once a year and do your service there.
So blades last about once a year,
So the blades, we check once a year. Usually the blades, it depends on the sludge, but usually at one end of the dryer, usually the feed end is where the blades wear the most. And so you basically run a string between the dryer with a set gap, and then you check the gap there. And the maintenance is pretty simple. It's nuts and bolts. It's unbolting and pulling the unit out. There's no heavy lifting. It's all supported by this trolley, and then you're just replacing the individual blades with these nuts and bolts right here. That's from a service standpoint. And then this is Middlesex. They have 5 dryers. They do service on 2 in the fall and 3 in the spring. So they will do their service toward the end of October, and then they usually do the other ones in the spring. They've been running since 2008. If you ever want to visit there, they're very open to visitors.
It's quite an impressive facility, and it's nice to see the inside of the dryer after over 10 years of running.
15 years or so, yeah.
And you can see the many conveyors that they've got zigzagging throughout the facility. Dried sludge going over to the lime silo. It's a nice little trip.
Do they have odor issues?
Yeah, they have thermal oxidizers. So they send all of the dryer exhaust to thermal oxidizers and basically burn it, which is what we would be basically the same thing if you send it back to an incinerator. But they use natural gas in their RTOs. But their facility, it's tough to, unless you're there, it's tough to really understand. But they have huge scrubbers because they used to mix this with cake, and this facility was like a lime and cake blending facility. So they have these huge scrubbers that's pulling air out of the operational area. But the dryers themselves, there's these 2 small thermal oxidizers that treat the dryer exhaust.
What are you defining as biosolids going into this?
I'm sorry?
What are you defining as biosolids that go into this?
So the definition of biosolids is typically something that's a class A. Before that, you consider it sludge. So the dryers here are really just drying sludge to sludge. They're not creating Class A biosolid until they put the lime in and they create the temperature and pH requirements for lime stabilization for the Class A biosolid. So there's a lot of ways to achieve Class A. Drying is one. Usually you're going to dry to less than 10% moisture. Make sure you get the temperature above 176 degrees and you have a Class A biosolid per the EPA rules. There's lime stabilization, there's digestion, there's a few other ways of achieving Class A. But I would say drying is the most cost-effective if you're looking to go just straight to a Class A product. It's usually the most cost-effective from a capital standpoint. Because an operation standpoint, as well. Lime stabilization usually requires a lot of people to be able to do that lime stabilization. So, I mean, that's basically all I had. If you guys have any questions, more than willing to answer them.
Are there any further questions?
No, good explanation.
Oh, no, thank you very much.
Tom?
Very interesting concept.
Thank you.
Yeah, thank you guys. We appreciate your time.
Yes, thank you.
Appreciate you coming in.
If you guys want a brochure or look at the machine,
Sure.
we've got some
Yeah.
brochures and cards and whatnot.
Yeah, I'll leave some cards here too if any of you guys want to contact me. So.
Thank you very much.
Thanks.
Thank you so much.
Okay. Item 5 is, Scott, you want to address 5?
What is number 5?
Oh, that-
Green Development notified us yesterday that they were going to pass on the opportunity to come and present to the committee.
Because of proprietary issues. Should have told us that 2 months.
Well, they had said that if we're interested in, proceeding to an RFP stage,
yeah.
they'd be interested. And this is just another example of, firms, it costs money for people to come.
Plane tickets to it.
Right. So,
But
all
let me
right.
ask you a question. Proprietary is protected by patents generally, isn't it? Technology.
It's one of the things that, patents, once you obtain your patent, it becomes public. Right. So proprietary means secret. They want to keep
Yeah.
it secret. So
the way they do
No,
their
I
things.
means and
understand.
methods, their way of doing business,
Right.
their methodology.
But if
Those
you're
are things you might not be able to patent those things, but they still want to keep it proprietary to them. They want to keep it to themselves.
So to commercialize it becomes
Yeah.
very difficult. Okay.
If you don't mind, they also indicated in their response to Lisa that just to answer our questions would have taken a lot of time and work.
That's probably a bigger issue.
And so they didn't want to invest in that unless it was a business opportunity.
I blame them.
Which makes sense.
That probably was Box's major issue was Box was in a lot of money.
Yeah.
Because they're an implementer, they're not a.
Right. But the decision was made after they got our questions, so it wasn't like
Yeah,
they wasted anyone's time. We had questions and they decided to opt out, that's all.
right. That's right.
Which is
they
fine.
did- They received a question. Okay, Kelly, what's our next meeting is?
Next meeting's next Thursday, the 28th.
And that would have been to sit and talk with staff about the LCI and green development proposals.
So then,
So it would be to talk about what we just discussed with LCI, their presentation.
and then we have what, Smith is the last?
2 weeks from next week, we have another meeting, I believe, John, to discuss CDM's proposal. Is that correct?
Yes.
And then the following 2
wanna
weeks
have
from
it
then
next week,
was
2 weeks.
CDM's presentation.
Yeah, no, so the next week's meeting is just to discuss the responses here. So we're happy to do that. The one thing that, and this is the type of technology that we are in the process, as you know, we got that $2.5 million grant for improvements to the incinerators through Congressman Lawson. So this would be a perfect example is when we're looking at that design of that, the cake receiving facility, this would be a perfect opportunity for us to analyze, does the pre-dryer
That
thing
too.
make sense?
Right.
As we're doing that, and it was good information for us to just kind of understand it, and when we do that design, we definitely will, on a preliminary level, say, does this make sense, you know? Whether it's this technology or somebody else's technology, does it make sense to implement this as part of that project?
But wasn't fluid bed one of the major issues?
Well, he gave us a lot of good information, you know, basically, we know this, and he confirmed it. Fluidized bed is the newest and latest, greatest technology for incineration, and when you're designing a new fluidized bed, you would weigh and make those decisions. Does this make sense? You know, it's a different way to do the end result, and the question is, does it work for you as the way that you process?
But wouldn't we have the opportunity to discuss that with Smith? Because they're gonna come
Sure.
and talk about.
Yeah,
fluid bed
absolutely.
too.
The fluidized bed is like we just mentioned, the fluidized bed in Middletown that was built about 6 years ago.
2016.
Or so, a little bit less than that, I think.
Yeah, 4 years ago. They did not put in a pre-dryer. Why, I don't know, but it's something to look at.
Didn't he say they put one in, but they didn't use theirs?
No, the one that we were talking about that has a pre-dryer, which pelletized, which
That
is
was
Stanford.
Stanford.
Stanford actually built a gasification unit years ago, back in the 90s.
When you say Middletown, you mean Connecticut?
Yeah.
'Cause
Yeah.
they were talking about Middletown, New Jersey.
Middletown, New Jersey.
Yeah, no, I'm talking about Middletown. I'm talking about Middletown, Connecticut has a fluidized bed, and they did not put in a
Yeah,
pre-dryer.
yeah, Right.
But others have, and I don't know the reasons, but it's something that you would weigh and consider.
But isn't that something Smith could?
Sure, absolutely.
You're convinced, though, there's no way that would go in the front of ours, makes any sense.
Yeah, well, it
I know there's a lot of
only
issues to do.
structurally,
I know
it's
not-
so
it's
much
not
to
big.
change,
I
you know,
understand.
physically change. And let's say it went, here's my question, you're gonna pick a number, $2 million more in gas, but are you gonna get the $2 million savings from 85% to 100%? I don't know, you know, and then you got the capital cost, so it just in quick look, probably not, but it's something to think about,
Well,
right?
Wouldn't it be a significant decarbonization?
No, you're gonna add carbon,
Because you're using
you're
more
burning,
gas, right, okay.
burning, the way in which you produce carbon is by burning natural gas,
Burning
right?
natural gas.
So if you're gonna burn natural gas at the plant,
No,
and you're
the
gonna
point
do
I'm
something that
saying-
burns more, you're gonna
The
create
point
more.
I'm saying is
carbon.
you're gonna have a clean air problem, a bigger.
Yeah, you're just gonna add to the existing carbon, so
Decarbonization,
you
right.
don't,
Doesn't though, if you burn natural gas in the dryer, wouldn't you be burning less in the incinerator, which was you're not taking into account? You just look at that number of gas you're doing now, but whatever you go into that dryer, you're gonna take off the incinerator side.
I agree with you. So they just said that it's about 5 million a year.
Yeah, so how much
We-
do you take off
We're spending about less than 3 million.
on the whole, so you already.
So let's say we get rid of 3 million, it's 2 million more. Easy math.
Yeah, I'm not convinced your numbers are
Wasn't
right.
the number
It doesn't make
2
sense to me,
million?
but okay.
For incinerator natural gas, it's about 2 million, maybe a bit.
2 million.
Yeah, 2 million.
That's
So
what's
if
in
they're
there.
5 and we're 2 and we get rid of our 2, we're still spending 5. You're spending 3 million more.
I'm just, it doesn't make sense to me.
5 minus 2 is.
I'm not,
Get your calculator out.
I'm not sure that you're gonna be happy about that.
Anyways,
I stopped at the 80 million. I was gonna do the calculation at the 80 million, it didn't make sense.
What did he do? They put 80 million instead
Instead
of
of
8?
eight.
But it's a mistake, yeah, it was a
I
mistake.
put at the end, how much
Yeah.
it costs, yeah.
Good,
But if you were starting from scratch,
I understand.
there's a lot of reasons why you might
Yeah, like
consider it,
Mechanically,
for
we have a
sure.
big problem too.
Yeah, yeah.
okay.
I'd like to know what it smells like in Middletown,
I was
where
just gonna
you've
say
got
that,
all that
please.
sludge cake, you know, on conveyor belts. It must not be a great environment for the employees. Is that?
All the people we've listened to come in, that was the smartest guy.
Yes, no, they know what they're doing.
They know what
Yeah, and it's real technology. It's real. I mean,
Now we know why CTEC can't show us any equipment in England.
No,
In
Germany.
Europe. No, it's all of Europe. He said they don't have, they,
Germany was the.
no, but the statement they said, and the answer to the questions was, you can't find them in Europe because of the energy balance, they stopped. Not to say you can't, but the
We
point
ought to
is
ask
the answers
that
are.
question, but
What?
they gave us a list of locations
Not the
where they're using gasification and,
in municipal waste? No, that was the point. Yeah,
well, hospital waste, whatever they're using it on,
well,
so.
He was
I mean,
pretty
I-
clear
there's
why they-
A lot of contradictions where he was coming from too, you know.
again, we were looking for that list, and there was no list because he says Europe has stopped doing it, so. And the-
Let's ask him that question.
Yeah.
Further questions? It's good.
My observation,
So,
I'm not member of the committee, but this is for a thirsty person is walking the Sahara Desert, and he sees all vapors, and he thinks it is all water. And here we are looking for something which we don't know. And we are starting looking into many, many different options for something which, in my opinion, at this point, it is not critical for this organization. We have an existing system. It needs to be tuned up little bit. And that's the only thing we should be looking at it, rather than spending a lot of time in all other. So far, nobody has come up with proven procedure, which is better than what we do. So my point is, why not to wait until somebody shows something somewhere else at their own cost? Because everybody's looking for money, our money, and experiment here.
well, this is only information that we're looking at. We're out there looking at the marketplace to find out what's there. This is not, we aren't going out for an RFP, we're going out for information. It's not something that we're spending enormous amounts of money to get into. You don't think we should look?
We can argue about it as much as, but in my opinion, this is not something, in my opinion, to focus on spending as much time and energy which we are spending on.
Fine, it's your opinion.
And that's my opinion.
Further issues, discussion? Opportunity for public comment?
Judy Allen, West Hartford. I have to address Teflon frying pans. they may not, they actually are moving towards banning the production of Teflon. But I saw a TV commercial just the other day for pots and pans, and they made a point of saying there's no PFAS in our pots and pans. It's consumer driven more than anything else. And I guess the other thing is I keep hearing about not having to meet EPA air standards for different parts of technology. That doesn't mean there's not any emissions. And I keep wondering, what are those emissions that they don't have to test? Just because they don't test them doesn't mean that they could cause a problem. That's it. Thank you.
Further comment? Commissioner's future agenda items, we have a future agenda item for 2 weeks from now?
2 weeks.
Next week.
Next week
Next
is
week
the
we do.
follow-up to this
Next week's the
meeting.
follow-up, the
And then
2 weeks would be
Yeah.
Smith.
10/12
CDM.
is the prep meeting for CDM.
Right.
Prep meeting for CDM, and CDM's coming in on the 19th.
10/26.
Would it be okay if we did next week's meeting, it would be short in the prep meeting for CDM? Instead of having 2 meetings, have one?
Yeah,
that make sense?
That makes some sense.
Because I don't think we have a lot that we didn't already say today.
Just said it.
Yeah, and but I do think that when we do our dryer
We
receiving
can come
facility,
back
that
and
we'll
take a look at
we'll
this.
look at this technology and you know, we'll analyze it at the design stage.
It should be interesting with Smith.
Completed our review of the CDM, proposal yet, so I'm.
Tom, can you speak
Combine
up?
our questions before next Thursday.
No, we're not. We're gonna 2 weeks.
So you're proposing to cancel next
Yes,
Thursday's
and
meeting?
then do this answers or discussion 2 weeks from now. Yeah,
Why
so
would
we're
we
gonna skip next week.
Why are we skipping next week now?
Well, because,
That much really.
10 minutes.
because it's not much to talk about here.
You'll combine it
So it just
together.
gives us a
That's
chance,
But can we move Smith up a week?
no,
No?
They're already scheduled for them.
Okay. That makes some sense.
yeah. Merge the two meetings, we'll talk about this in
So-
5 minutes.
So what we'll do is, we'll eliminate next week. In 2 weeks, we'll combine
On 10,
what's
12.
there. Because they're
Yes.
talking about fluidized bed,
They'll be talking about fluidized bed, yeah.
which would give us more, I'm sure they know what's going on in New Jersey.
Oh, yeah, no, obviously fluidized bed is a very standard, I mean, this gentleman just mentioned Germany's going to fluidized beds, right? So it is a standard in the industry, for new incineration. The question is whether or not, you know, you could get a permit, from Connecticut Deep or anywhere with a new incinerator, at all. So that's the big question for everyone. And that's what that study EPA is doing on
Yeah, they're never-
capacity
they're never gonna
analysis.
approve it.
Jersey, I'm pretending to guess that they're probably a little more, less strict. You know, there's a lot
From here to on.
there's a lot of, biosolids being trucked down to Jersey, land application. So they're allowing things, and I believe this gentleman's right. You know, the sky is falling, Maine banned land application. Massachusetts banned, landfill application, land application. I think there's gonna come a point where EPA is gonna have to stand up and say, to your point, you know, we're not gonna solve this problem in 5 years, 10 years. They have said, EPA's report has said that all of us have so much PFAS in our bodies from, you know, using Teflon pans for the last, 40 years, that you'll never, ever, you can't remove it from our bodies. So almost everyone in the population today has some form of, levels of PFAS in their body that you can't get out. So I don't know
If
what,
it's dangerous and you got people that are being born, it's gonna affect. them.
right, I don't know what EPA is gonna do about the regulation. And that's why we talked about all this water testing that we're doing across the country. You'll know in about 5 years, or less, 4 years, you'll know where EPA stands on this. Once all this water testing data comes in under our UCMR program.
Is that before or after stormwater?
Yeah, stormwater's a whole nother problem.
We showed up.
General question, based on what Commissioner Patel said, the main reason for this whole thing was to look at potential revenue streams and savings. Are we at the end of this thing gonna have a discussion in this group about municipal solid waste? Is that something we wanna do or not do? To
Right,
me, it's very important.
sure.
'Cause for me, I think we're the group that could do it, based on
Right.
the size.
Yeah.
And someone should make a decision, are we interested or not? And
Right,
either go look at it or forget about it.
right.
I
Well,
think that needs to be the result of this,
I
right?
think you're right, because I think that's right now on the burner that they're looking at.
Absolutely, that's what, I was saying at the end, I mean, he was saying why, we're not my opinion, we're not wasting our time if we all conclude, and that's a huge direction to go, but, you know.
Yeah, it would give us a better perspective. of
Perspective
what-
how to
what
do
we're
it.
gonna do from a planning standpoint. Because that's the hot one, it's on
That's
the
the hot
burner right away. They got, what, 3 years, 4 years to do something, they're
Yeah.
shipping it now, and everybody, the legislature just couldn't get together on where they wanted to go totally.
Anyways, okay, very good. That was just quick.
So we'll see what deep is, deep, it is, comes down
Yeah.
to deep. And
Yeah, it's all comes down to permanent cost.
Down in deep.
Yeah.
Yeah.
Okay, is a motion to adjourn in order?
Yeah.
Without objection, we
Thank you.
stand adjourned.
I- I'm-
All right, thank you.